Good day everyone, I'm Teacher TINZ and welcome to my YouTube channel. In this video, we will discuss about theorems on angle formed by tangent and secant line. Before we will discuss theorems on angle formed by tangent and secant lines, let us define first tangent line. Tangent line is a line that intersects circle at exactly one point. Let us consider now circle A. And this will be the illustration of tangent line. Line BC is tangent of circle A, wherein point B is the point of tangency. So this is now the point of tangency, wherein the point of tangency is the point where a tangent line touches the circle. Secant line is a line which intersects circle at two distinct points, and this will be the illustration of secant line. Line ED is a secant of circle A, wherein the two distinct points are point E and point D. So the line or secant line intersects circle A at point E and point D. Let us consider circle M. We will determine which of the given lines illustrate as secant or tangent. First is we're going to determine the tangent lines. So here we have line segment GL and line segment IJ are the tangent lines of circle M, wherein the point of tangency in line segment GL is point G. And the point of tangency in line segment IJ is point I. For the secant lines, we have line segment GK, line segment GH, and line segment KH. Let us discuss now theorems on angle formed by tangent and secant lines. The external angle theorem. When two tangents, a secant and a tangent, or two secants intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. Let us consider now circle S. So as you can see in the illustration, we have two tangents, which are line AB, and the point of tangency is point B, and line AC, the point of tangency is point C. So here, the measure of angle BAC is equal to 1/2 times the measure of arc BDC minus the measure of arc BC. Another illustration, we have circle T. So as you can see in circle T, we have a tangent and a secant. So the tangent line is line AG, the point of tangency is point G, and the secant line is line FH. So here, we can say that by applying the external angle theorem, angle FEG is equal to 1/2 times the measure of arc HG minus the measure of arc FG. And the third illustration, we have circle V. So as you can see in the illustration, we have two secants, so which are line JM and line KN. So here, by applying the theorem, we can say that the measure of angle MIN is equal to 1/2 times the measure of JK minus the measure of arc MN. Let's have examples on how to determine the measures of angle formed by two tangents. In example number 1, what is the measure of angle PQR in the figure below? So here we have circle A, and in circle A, we have tangent or line PQ. that is the tangent line. And line RQ is also the tangent line, wherein point P is the point of tangency of line PQ, and point R is the point of tangency of line RQ. And for the given, the measure of arc PR is 100 degrees. So the measure of this arc is 100 degrees. And we're going to find the measure of angle PQR. So this is now the angle formed by the two lines, by two tangents, which is located outside the circle. So for the solution, first is we're going to determine the measure of arc PSR. We need to know the measure of this arc. And the measure of PSR is equal to 360 degrees minus 100 degrees. And the measure of arc PSR is 260 degrees. Next is we're going to solve for the measure of angle PQR by applying the external angle theorem. So the measure of angle PQR is equal to 1/2 times the measure of arc PSR minus the measure of arc PR. So by substitution, we have the measure of angle PQR is equal to 1/2 times the measure of arc PSR is 260 degrees minus the measure of arc PR is 100 degrees. And then simplify, 260 degrees minus 100 degrees is 160 degrees. And then after that, we're going to get the half of 160 degrees. So the answer is 80 degrees. Therefore, the measure of angle PQR is 80 degrees. Example number 2. What is the measure of angle IHJ in the figure below? We have circle A. So given the measure of arc IJ, this is arc IJ, is 120 degrees. And we're going to find the measure of angle IHJ. So this is the angle formed by the two tangents, which is located outside the circle. And then for the solution, first is we're going to solve for the value of arc IKJ, wherein the measure of arc IKJ is equal to 360 degrees minus the measure of arc IJ, which is 120 degrees. And simplify, 360 degrees minus 120 degrees. So the measure of arc IKJ is 240 degrees. Next is we're going to solve for the measure of angle IHJ, and that is equal to 1/2 times the measure of arc IKJ minus the measure of arc IJ. And by substitution, the measure of angle IHJ is equal to 1/2 times 240 degrees. This is the measure of arc IKJ minus 120 degrees. This is the measure of arc IJ. And simplify, 240 degrees minus 120 degrees is equal to 120 degrees. And then get the half of 120 degrees. So the answer is 60 degrees. Therefore, the measure of angle IHJ is equal to 60 degrees. For example number 3, what is the measure of arc SR in the figure below? We have here circle C, and line RT and line ST are the two tangents of circle C. So here, the given is the measure of angle STR, which is equal to 80 degrees. The measure of angle STR is 80 degrees. Angle STR, that is the angle formed by the two tangents. And we're going to find the measure of arc SR. So for the solution, we have the measure of angle STR is equal to 1/2 times 360 degrees minus the measure of arc SR. That is the measure of arc SUR. 360 degrees minus arc SR is the measure of arc SUR. And then minus the measure of arc SR by applying the external angle theorem. And by substitution, we have the measure of, or simplifying first the equation, the measure of angle STR is equal to 1/2 times 360 degrees minus 2 the measure of arc SR. So here, how did we get 2 measures of arc SR? So here we have 1 arc SR plus 1 arc SR is equal to 2 arc SR. And then simplify, we're going to get the half of 360 degrees and the half of 2 arc SR. And we're going to substitute the value of angle STR. So here we have the measure of angle STR is 80 degrees. The half of 360 degrees is 180 degrees. And 2 arc SR divided by 2 is equal to arc SR. Next is we're going to add or apply the addition property of equality. So we're going to add negative 80 to both sides of the equation and positive arc SR. And we have the measure of arc SR is equal to 180 degrees minus 80 degrees. And then simplify, 180 degrees minus 80 degrees is equal to 100 degrees. So the measure of arc SR is equal to 100 degrees. Let's have now examples on how to determine the measures of angles or angle formed by tangent and secant. So we have example number 4. What is the measure of angle HGI in the figure below? We have here circle C. So this is now circle C, and the tangent line is line GH. The point of tangency is point H, and line GK is the secant line. And for the given, the measure of arc HI, this is arc HI, is 50 degrees, and the measure of arc HK, this is arc HK, is 110 degrees. So we're going to find now the measure of angle HGI. Angle HGI is the angle formed by the tangent and the secant. So for the solution, we will apply now the external angle theorem. So the measure of angle HGI is equal to 1/2 the measure of arc HK minus the measure of arc HI. And substitution, we have the measure of angle HGI equals 1/2 times the measure of arc HK is 110 degrees, and then minus the measure of arc HI is 50 degrees. Next is we're going to simplify 110 degrees minus 50 degrees, so the answer is 60 degrees. And then next is we're going to get the half of 60 degrees, so the measure of angle HGI is 30 degrees. Another example, example number 5. What is the measure of angle BBC in the figure below? So we have This is angle DBC. Okay, so we have arc AC, this is arc AC, is equal to 70 degrees, and arc CD, this is arc CD, is equal to 150 degrees. So we're going to find the measure of angle DBC. For the solution, we're going to apply again the external angle theorem. So we have angle DBC is equal to 1/2 times the measure of arc CD minus the measure of arc AC. So we're going to substitute the measure of arc AC and arc CD in the equation. So we have the measure of angle DBC is equal to 1/2 times 150 degrees is the measure of arc CD, and 70 degrees is the measure of arc AC. And then next is we're going to simplify 150 degrees minus 70 degrees is equal to 80 degrees. Next is we're going to get the half of 80 degrees, so the half is 40 degrees. So therefore, the measure of angle DBC is 40 degrees. Let's have example number 6. What is the measure of arc DC in the figure below? We have here circle E. So this is now circle E, and the tangent is line BC, and the secant is line BD. So for the given, the measure of arc AC is 90 degrees. The measure of this arc is 90 degrees, and the measure of angle ABC is 55 degrees. And we're going to find the measure of arc DC. We're going to find the measure of this arc. For the solution, we have the measure of angle ABC is equal to 1/2 times the measure of arc DC minus the measure of arc AC. So the measure of angle ABC is equal to 1/2 the measure of arc DC minus the measure of arc AC. And for the substitution, we have the measure of angle ABC is given, that is 55 degrees, equals 1/2 times the measure of the arc DC, this is unknown, and the measure of arc AC is 90 degrees. And then we're going to simplify the equation. We're going to multiply the equation by 2, and we have 2 times 55 degrees is equal to the measure of arc DC minus 90 degrees. So here, we will multiply the left side and right side of the equation by 2. So if we will multiply 1/2 by 2, the answer is 1. That's why we have the measure of arc DC minus 90 degrees at the right side of the equation. And then 2 times 55 degrees is equal to 110 degrees. And then we're going to add 90 degrees to both sides of the equation. So we have 110 degrees plus 90 degrees. And that will be the measure of arc DC. Simplify now 110 degrees and 90 degrees. So we're going to get the sum, and the sum is 200 degrees. So therefore, the measure of arc DC is equal to 200 degrees. Let's have now examples on how to determine the measures of angle formed by two secants. For example number 7, what is the measure of angle NMQ in the figure below? So in the given figure, we have circle E. So this is now circle E, and line MO and line MP are the two secants of circle E. So for the given, the measure of arc OP, this is arc OP, 50 degrees, and the measure of arc NQ, this is arc NQ, is 30 degrees. So we're going to find the measure of angle NMQ. And for the solution, we're going to apply now the external angle theorem. So we have the measure of angle NMQ is equal to 1/2 times the measure of arc OP minus the measure of arc NQ. And substitution, so we have angle NMQ is equal to 1/2 times the measure of arc OP is 50 degrees and the measure of arc NQ is 30 degrees. So we have 50 degrees minus 30 degrees is equal to 20 degrees. And the half of 20 degrees is 10 degrees. So therefore, the measure of angle NMQ is equal to 10 degrees. For example number 8, what is the measure of angle SRT in the figure below? In the given illustration, we have circle T. So the two secants are line VR and line UR. So for the given, the measure of arc ST is 50 degrees and the measure of arc UV is 150 degrees. So we're going to find the measure of angle SRT. So for the solution, by applying the external angle form or the external angle theorem, we have the measure of angle SRT is equal to 1/2 times the measure of arc UV minus the measure of arc ST. And next is we're going to substitute now the values for arc UV and arc ST. So we have the measure of angle SRT is equal to 1/2 times 150. This is the measure of arc UV minus 50 degrees. This is the measure of arc ST. And then simplify 150 degrees minus 50 degrees, that is equal to 100 degrees. And we're going to get the half of 100 degrees, so the answer is 50 degrees. So therefore, the measure of angle SRT is 50 degrees. For example number 9, what is the measure of arc BC in the figure below? So this is arc BC. And we have circle F. So for the given, the measure of arc AD, this is arc AD, the measure is 50 degrees, and the measure of angle AED is 45 degrees. So we're going to find the measure of arc BC. For the solution, by applying the external angle theorem, so we have the measure of angle AED is equal to 1/2 times the measure of arc BC minus the measure of arc AD. So we're going to substitute now the given. So we have the measure of angle AED is 45 degrees. So we will change the measure of angle AED into 45 degrees. And then equals 1/2 times the measure of arc BC minus the measure of arc AD is given, so that is 50 degrees. So we will change this one into 50 degrees. And then next is we're going to simplify. So we're going to multiply the equation by 2. That's why we have 2 times 45 degrees is equal to, so here 1/2 times 2 is equal to 1 times the measure of arc BC minus 50 equals the measure of arc BC minus 50 degrees. And then next is we're going to simplify. So the measure of arc BC is equal to 90 degrees plus 50 degrees. So how did we get 90 degrees? That is the product of 2 and 45 degrees. 2 times 45 degrees is equal to 90 degrees. And then if we're going to apply the addition property of equality by adding 50 degrees to both sides of the equation, so we have here 50 degrees. So 90 degrees plus 50 degrees is equal to 140 degrees. So therefore, the measure of arc BC is 140 degrees. Thank you for watching. Please don't forget to like, share, and subscribe.